The first step in a proof by contradiction is to assume the opposite of what we want to prove. Here we want to prove that the square root of 2 is an irrational number, so we start by assuming it's a rational number. If that's the case, then the square root of 2 is equal to some ratio, a over b. Let's assume that a over b is at its lowest terms. That means we can't divide through by any common factor, so we can't have the case where a and b are both even. If the square root of 2 is equal to the ratio of a over b, then 2 is equal to a squared over b squared. This implies that 2b squared is equal to a squared. If we multiply any number by 2, we end up with an even number. So a squared is even. And from that we can say that a is even. If a is even, this implies a is equal to 2k, where k is just some arbitrary value there. We can substitute for a into the equation above, where we have a 2 is equal to a squared on b squared. So we'll have that's equal to 2k squared on b squared. This implies that 2b squared is equal to 4k squared. We can divide through by 2, and so we'll have b squared is equal to 2k squared. Well, if b squared is equal to 2k squared, this implies that b squared is even. And here's the contradiction. We can't have the case where both a squared and b squared are even. Since our proof contradicts the original assumption that the square root of 2 is equal to the ratio of a over b, and then we can say that the square root of 2 is not rational. Which completes our proof.